We discuss the experiment of calibration and use of measuring instruments, Vernier Caliper, Vernier Height Gauge, and Micrometer. Aim of this experiment to compare the accuracy of Vernier Caliper, Micrometer, and Vernier Height Gauge, and it is to check the various dimensions of given specimen. To compare the accuracy of Vernier Caliper, Micrometer, and Vernier Height Gauge to check the various dimensions of given specimen. Apparatus required: Vernier Caliper, micrometer, Vernier height gauge, and different specimens by also using slip gauges. Then now we can move for the procedure for Vernier caliper and a height gauge. First, to check the zero setting for error. Second, we place the workpiece to be measured in between the measuring faces. Then another one is adjust the sliding jaw until there is no further movement of sliding bar. Then note the main scale Vernier reading for calculation of workpiece dimensions. Fifth one, tabulate the readings. Then the dimensions of workpiece is calculated and average value is taken. The next one, procedure for micrometer. So to check the zero position for error, place the specimen to be measured. Adjust the spindle by rotating the ratchet until it begins to slip. Note the reading on the main scale and the thimble scale reading. Then by calculating the divisions on both scales, the reading was tabulated. Thus the thickness of the workpiece was measured. Yes. Now, how we'll calculate by the least count Vernier caliper and Vernier height gauge? Okay, so here the Vernier caliper. So Vernier caliper main scale division is which is noted at here 0 to 0 is that 50 divisions from the Vernier scale division. So here noted from that 49 divisions have to engaged by the main scale divisions. Okay, so that's why we noted here 49 main scale divisions have mentioned by the main scale reading, and 50 Vernier scale division is each one we have in 5 mm. So 5, 10, 15 like that we have to consider yes up to 0 to 0 50 Vernier scale divisions. Okay, so we have considering from that one Vernier scale division is 49 divided by 50. Okay, so the answer is 0.98 mm to the one Vernier scale divisions, considering as a one Vernier scale division. So finally we can calculate by the least count is 1 MSD minus 1 VSD. Okay, so which is the 1 mm is the deviation. No, we can considering as that to be here is 1 mm. Okay, minus already we have to calculate it as the 0.98 mm. Okay, so 1 minus 0.98 mm, so we can get as the 0.02 mm by the least count of Vernier caliper. Similarly, Vernier height gauge. So now we have to calculate by the least count of the micrometer. To be noted here is the pitch distance. So in bottom of the main scale reading we have considering as each one pitch distance is 0.5 mm. Okay, so in full rotation of the thimble scale value is 45 up to 45, 46, 47, 48, 49, 50. Okay, so that is a total number of the division in thimble scale reading is 50. Okay, so directly we have to calculate it as 0.5 by 50 is equal to 0.01 mm was measured. Yes. These are the tabulations we are using Vernier caliper and Vernier height gauge and also micrometer. So first we are calculated by that slip gauge is inside. So it is already we know that this different standards already available in the slip gauge set. Then main scale reading which is noted as the main scale reading of Vernier caliper. Then Vernier scale coincidence. So that is meaning of VSC or VSR, then which is noted as the Vernier scale reading coincident. Then Vernier scale reading, then VSC into least count, then measured dimensions MSR plus VSR into least count already we are calculated here. So finally we can get it here for the error. So similarly we have to take it the different slip gauges like 16.5 or 17.5 up to 20 or 25 like that. Then calibrations of Vernier height gauge. So it is also the least count is 0.02 mm. Similarly for Vernier caliper. So that specimens already we are fixing here that different heights of the different height of the ms steels. Then main scale reading, first there should be noted from here main scale reading, then vernier scale reading, then vernier scale reading is equal to vsc into lc, that is called as vernier scale reading. Then measure dimensions msr plus vsr, finally we can calculate it by the average. Micrometer. So the micrometer, calibrations of micrometers, calculations like different standard slip gauges, then main scale reading, then noted by the thimble scale reading, coincident thimble scale reading. So that thimble scale reading which is calculated as TSC into least count, then measure dimensions MSR plus TSR, which is calculated MSR into plus TSR. So the finally we can get as the error value. So these are the formulas we can get as the micrometer. Model graph of this experiment. So we are noted here the actual reading is in x-axis, then y-axis for the indicating reading. So gradually increase from that reading values, which is it is at correct values you can get from this experiment. The finally the results, length of the specimen, then height of the specimen, the thickness of the specimen, thus the accuracy of Vernier Caliper, Vernier Height Gauge, micrometer compared the given specimens. That's it. Okay, now we have how we'll take the reading by using the Vernier Caliper. So this is the ranges from 0 to 300 mm of the Vernier Caliper. So 0 is here and 30 centimeter is here. So that is calculated is in 30 centimeter into mm, 30 into 10, 300 mm. So the ranges is 0 to 300 mm. Okay, that is a main scale reading. Then now we can move this Vernier scale reading 0 to 0. We have in each one 5 divisions. 0 to 0, each one 5 divisions. Then 0 to 1 5 divisions. Then 1 to 2 5 divisions. Up to 10, up to 0 we can get as the 50 divisions of the Vernier scale divisions. Okay, so that is the Vernier scale reading. So we can take these slips here 16. So this is a slip gauge, is the dimensions of slip is 16 mm. Okay, so now the checking the reading of Vernier Caliper of the main scale reading is in 16 mm. Directly get as the 16 mm from the Vernier Caliper. Okay, then another one we can check it here, the dimensions of the Vernier scale, which is located as the nearly 6. Okay, nearly 6 by the Vernier Caliper reading. Okay, so like we can get as the reading 0 to 1 up to 6, 30 mm. So here noted from that reading by the tabulations. So slip gauge we can considering as 16, then main scale reading directly getting as 16, then Vernier scale reading coincident, so that is called as VSC, so that is already been noted as 30 mm. Okay, then the Vernier scale reading is VSC into least count, so already we know that is the least count of the Vernier Caliper is 0.02, so that is 0.6. Then measured the dimensions of the slip gauge 16 mm, so 16 is the main scale reading and 0.6 is the Vernier scale reading. Okay, now we can get as the final reading of the first slip gauge, that is 16 mm. So 16 mm is the main scale reading plus 0.6 as the Vernier scale reading. So finally we can get 16.6 mm by the overall value of the 16 mm of slip gauge. So we can get it here the dimensions of error of this slip gauge. So already is 16, you know, right? 16 minus 16.6, 0.6 mm is the error of the slip gauge. Now we have to calculate by using the Vernier height gauge by the different specimens. Okay, so we are considering now this is the clearance of the Vernier height gauge, so which is already the measured standard clearance value is 20 mm. Okay, after we can get the specimen of the height plus 20 mm we have to add, that is the clearance amount we have to add after that specimen value. Okay, so how we'll take the reading by using the Vernier Caliper now. Okay, so first we can fix the face of the Vernier height gauge. Okay, so here it is noted the Vernier Caliper reading value and main scale reading value. Okay, so that is 0 to nearly, which is noted from is 65 mm. Okay, then this is called as a main scale reading. Then here is noted here from the main scale Vernier scale reading, that is 0, 1, 2, 3 and 4. Okay, so that is a clearance you can get as the value from that main scale Vernier scale reading 0 to 4. Okay, so each one have 5 divisions. So 5, 10, 20, 5, 10, 15 and 20 mm. Okay, so this is the Vernier scale reading. Okay, here mentioned that the main scale reading is 65 mm. Vernier scale reading is, that is coincident reading is 20. So that Vernier scale reading is 20 into 0.02 0.4 mm. So the measured dimensions value already we know that 65 mm. So plus 0.4 equal to 60.4. Okay, so this is the measured dimensions by the specimen. So the 65.4 minus of 65, the answer is error of this specimen is 0.4 mm. Now we have to calculate the reading by using micrometer. So we can take it here, the 10 mm slip gauge. Okay, so to be fixing in between the anvils, so 10 mm by the slip gauge. Okay, so after we can fix that to be closed by the lock nut. Okay, so we can note it here, the main scale reading and thimble scale reading by using two micrometer. So we can note it here, that is called as upper the value is mentioned is, which is called as the main scale reading. So we can calculate it here almost nearly each one have 1 mm. So 0.02.025 it is 5 mm, 6, 7, 8 and 9. Okay, so that is called as upper value we can get as the main scale reading is 9 mm. Okay, then similarly we can get as the lower value, each one value is 0.5 mm. Okay, so which is noted as the each one value is 0.5 mm. So we can calculate it here is 10. Okay, so 10 into 0.5 is equal to 5. Okay, that is a thimble scale reading is 5. Okay, so that the thimble scale reading 5 into 0.01, so 0.05 from that. Okay, so that 0.05 is the reading value of the thimble scale reading. 5 into 0.01, 0.05. Okay, so measured the dimensions value, ms are already we know that, so the 9 mm. So the thimble scale reading is 0.05, so equal to 9.05 is the reading to be measured by using the slip gauges of 9 mm. So finally we can get 9.05 and a minus of 9 mm we can get as the 0.05 mm error by using the micrometer.